Okie doke. It's 4 o'clock Eastern time. Sunny day in Tampa, Florida, and we're going to get started. Thank everybody for coming. I'll do a little introduction a little bit later, but people will join us at different times, and there's different time zones and all kinds of stuff. So we'll let people chime in. But again, this webinar is focused on how to prevent corrosion on your cranes. Just so everybody knows, we have several people that signed up are from non-crane folks, but we have some amusement ride folks, some trucking folks, some heavy equipment operators in the mine. So we have, well, I'm going to focus mostly on cranes. There is some applications for everybody else. So let's start. What are we going to cover today? Hey, we're going to talk about all the different types of corrosion that affect your business. So what is corrosion? What types of corrosion? And at the end, we're going to talk about how to treat corrosion, how to prevent corrosion. And on the last one, I really want to talk about the role of inspectors, particularly my friends in the crane inspecting world and those in the amusement ride world. We're going to talk about the role of an inspector and what you can do on your reports and how you can convey to your customers that, hey, you need to take care of this corrosion before something bad happens. This is audience participation. I really appreciate you guys sending in your questions. Just type it in the chat, or you can send emails and I'll answer them if I get them later after the webinar. But please use the chat. We're going to have a couple question and answer periods. So just type it in the chat. We'll get Ron here to answer them. I'm DJenkins, as you can see. Over here, right here, that's me almost 20 years ago, my first forklift accident. I was a forklift accident investigator. And that machine turned over, and upon review, I found out he made a homemade boom extension, and it was completely corroded. And so that was my first experience with accidents on heavy equipment and corrosion. I went on to be heavily involved in crane accident prevention for about 8 or 9 years. I did everything I could possibly to prevent a crane accident, and which led me to a lot to the offshore crane world, where they had serious corrosion. And over here on the right, I ended up getting to a pretty high level with the federal government, and I actually put on schools for the federal government on how to learn about inspecting cranes. And that's me down here on the right with 2 guys out of Washington, D.C. that were tasked with preventing crane accidents offshore. And yes, you know, welding, operator error, but a lot of corrosion issues. We're not going to talk about wire rope today, but a lot of corrosion on the base and so forth. So we'll talk about that. The other presenter is Ron Knight. There's a picture of him right there. He consults the United States Air Force on corrosion, makes products for the Air Force, and also some of the nastiest and harshest environments known to man, which include pulp and paper mills. We have products inside these mills that have incredible high acid. And this one right here, we have an ongoing project with large manufacturer of equipment, restores beach equipment, restores beaches, and their equipment is literally falling apart in a year or so. And we help them extend the life of that equipment. So that's Ron, incredibly knowledgeable. We're blessed to have him. Okay, so let's get started. Where does corrosion happen? Particularly on the crane. Nuts and bolts, fasteners, plates, safety devices. So we'll be talking a lot about nuts and bolts today. We're going to be talking a lot about the boom section. Right here, as you can see, whoop, I just circled it all. Crack on the top of a boom leads to corrosion. Small corrosion turns into big corrosion. I got a lot of pictures of booms. Anybody wants to send me more pictures of corrosion on booms? I'd love to get my hands on them. Okay, and thank you to the inspectors who sent in a lot of photos. Yep. We're going to talk about corrosion underneath the crane. A lot of structural members. A lot of braces. So corrosion's everywhere, particularly in the hot, humid areas where salt and stuff rises from the ground and just basically eats the bottom of machines. So we'll talk about that. And of course, anything safety is we're going to talk about, but here's a good picture my friend Donald sent me. We have corrosion on a lot of electronics. They have a lot of metal. So if you have problems with safety switches and electrical connectors and wiring that are corroded, I got the man here, right here to answer your questions. I want you to take a quick look at this picture. This is a crane set up There's a lot of things wrong with this picture, but I want to focus right down here, right down here, right down here, and right down here. What do you think we're going to find? Obviously, it's not set up right, the cribbing's not right, it's uneven ground, etc. But as you can see, the components have corrosion on them. Again, corrosion on the components. We have to stop corrosion on critical components, and that is a critical component. Not good. So the combination of corrosion, not setting up right, probably some operator error. If you have an accident, you're not the place you want to be. So before we get into some details, but I just want to share with you, corrosion is more than cosmetic. And you inspectors out there, you have to really relay that to your boss, your client, that it really affects maintenance costs. A lot of these cranes today cost $2 and $3 million. They're supposed to last 15 years. A lot of them are only lasting 7 and 8 years. So we got to talk to them about why you need to take care of corrosion, because it's about equipment replacement costs. Obviously, if the crane ain't working, or the amusement ride ain't working, or the gas station ain't pumping, you have downtime. And my passion is the worker safety side. So accidents do happen, and we're going to do everything we can to help prevent them. So again, this is open forum. Please answer your questions as we can. I also surveyed people from all over the United States, Panama, Canada, Hawaii. Where's corrosion happen? It's everywhere. It doesn't matter if it's dry, humid, low altitude, high altitude, snowing. Corrosion happens in all parts of the United States. And today we're going to talk a lot about the environment where you live. Maybe you live next to a power plant. Maybe you live next to a chemical plant. Maybe your crane operates on the beach. So we're going to talk a lot about the environment today and how that can help you. Again, I got a couple corrosion pictures here, but you can see the safety pin is missing, and the guy put in a homemade bolt, and it's still corroded. So corrosion's everywhere, even on replacement parts. I got a good picture of some pitting corrosion on top of a boom. Small corrosion turns into big corrosion. And here's a little more detailed look at some corrosion on the top of a boom. Particularly this equipment that sits outside a lot. The rain accumulates on it, the salt water creates corrosion. Another picture. Here's a picture I just took in Tampa, Florida. It's a guy who tried to paint over corrosion. Not good. We'll be talking a lot about paint later and how it impacts corrosion and the good parts about paint, and there's a lot of bad things about paint. So we're going to talk about that. As you can see, his paint didn't work. He didn't stop the rust. So for now, I'm going to turn it over to Ron, and he's going to talk to you a little more about the types of corrosion and definitions of corrosion.
Good afternoon, everybody. The definition of corrosion is really pretty simple. None of the metals that we have, with the exception of gold, are found in their natural state. Iron and steel and aluminum are all oxides of something else. And all corrosion really is the return of the metals to their normal oxidized state. In other words, steel will try to go back to iron oxides, aluminum will try to go back to aluminum oxides. There's a number of kinds of corrosion, 8 or 10 or whatever, and that's a whole class in itself. Depending on, or because of the subject we're talking about today is heavy equipment, we're going to talk about uniform, localized, environmental cracking, and fretting. We could talk about the other ones if you have specific questions, but that's the 4 that I want to cover mostly. Uniform corrosion, you can read the most common type of corrosion, destroys the metal, slow moving, easy to monitor, and correctable in a PM situation, planned maintenance. Do you remember the pictures of the crane that looked kind of orange and whatever? That's regular old uniform corrosion. It's a pain, but it's very easy to monitor. There's no real surprises, and what you have to do is fix it before it gets too bad. And if it doesn't get too bad, it'll reduce the thickness of the metal, and we'll get into some other areas, but what you're going to get is a fatigue break because the metal won't support the stresses and strains that's put on it. Localized corrosion is, as you see there, is really dangerous. Instead of being spread out, there's three basic kinds of corrosion. It's pitting, crevice, and filiform. Do you remember, I think there was a bolt or something in the beginning where it was really rusted? So filiform is the kind of rust that occurs under a plating or under paint. Pitting, my opinion, is probably the worst kind of corrosion there is, and the reason for that is it's very small. You can't see it without very close inspection. There will be a picture, I think a couple of slides down, but basically pitting corrosion will lead to catastrophic failures. Crevice corrosion is exactly what it says. Remember on the one slide there was a crack in the piece of crane that was corroding. What that really is for whatever reason there's a crevice or a crack, or where two pieces of metal come together. Corrosion requires two products. Corrosion, in order for something to corrode, you have to have moisture and water. Do you remember there was a slide there of the undercarriage of something? Well, what's happened is that I-beam or whatever was flat and allowed water to pool and lay there and ultimately corrode. That same liquid would creep into cracks and crevices and create a problem, and all three of those, pitting, crevice, and filiform, can lead to catastrophic failures. Environmental cracking. This is kind of an extension of the other cracking that we were talking about. And again, it's extremely dangerous. You have where it says stress corrosion cracking. That would be very evident in a crane on the boom. As the boom is under load, the bottom side of the boom is under compression and the top of the boom is under stress. And we'll talk about that a little bit more. Another one that is coming up, I'm working on a project right now, as a matter of fact, is hydrogen-induced cracking. Hydrogen actually is absorbed into the upper crystals of a metal, and that metal, the one I'm working on right now, happens to be aluminum. But what happens is the metal becomes very hard or brittle, loses all ductility, and is really subject to cracking and then breaking. Corrosion fatigue, that's a big, we talked a minute ago on the electrical connectors and that. That's one of the things. Here's something that you may have done. If you take a piece of wire in your hand, it doesn't have to be corroded, but if you take a piece of wire and wiggle it back and forth and back and forth and back and forth, sooner or later that's going to break. That's due to fatigue. Environmental cracking can be caused by, and this is, I think, the most important thing, is reaction of metal to environments. Chemicals can cause it. For example, coal-fired generating plants, they use coal, sulfur's giving off, it mixes with humidity and comes down as acid vapor, and it will destroy any of the metals. If you live by a sewage treatment plant, there's hydrogen sulfide, turns into sulfuric acid. If you live by a pulp mill, again, you get acid vapors. So there's a lot of environmental causes for environmental cracking. Temperature extremes, when I used to design actually equipment, we used this big service factor, so it's not as prevalent as it should be. In other words, if you think a half-inch will work, you use 3/4. What temperature can do, and I've seen this happen, I used to work for a very large company, and I ran around the world looking at broken equipment and then had to decide why it broke. I had a problem on a chain conveyor in a coal mine, and what happened is the guy who was welding the what we called attachments on the chain, it was hot, so he had a fan and he was cooling the steel, and his steel, in other words, he was trying to cool himself, but he basically air quenched the steel and it made it brittle and not ductile. Moisture is the same thing. We have to have moisture to have corrosion, but in that moisture you can have acids, you can have chlorides, just a myriad of things besides the water. So environmental cracking is stress cracking that you're not going to see until it's too late. Fretting corrosion. We do a lot of business with companies that use electrical connectors. And as it says there, fretting corrosion is caused by unlubricated movement. Airplanes, cars, cranes, anything moves and vibrates. If it's not adequately lubricated, you get tip-to-tip contact, then you get arcing, and then you get galling, and then the metal, I've seen metal, think of a bearing that runs dry where it actually freezes together. We do a lot of work in that area, and some of the lubricants that you would use or should be using have to be sized by the molecular size of the molecule. In other words, if a piece of equipment has low or close manufacturing tolerances, you can't use a big fat lubricant molecule to get in a little crack. It'd be kind of like trying to stuff a ping pong ball under a door. So you have to use the appropriate lubricant to avoid fretting corrosion. Fretting corrosion, again, is inside stuff. It's very, very hard to detect. The vibration rubbing of parts is, I'm on the F-16 working group, and a lot of early problems on the F-16 had to do with the fact that it's not a stable platform. The same thing could be said of cranes or any moving piece of equipment where you have short cycle vibrations. All of the above causes the pitting, and I said the galling, where you actually have the metal pulling apart like off of a shaft or freezing up of bearings. And the fretting corrosion, as it gets worse and worse, leads to stress risers. And there's a good picture, and I'll talk about stress risers and tensile failures in a minute, but that whole mess can be a result of lack of lubrication. Here it is. This is a corrosion pit. If you look at the left side of that pin, a little above 9 o'clock, you'll see a kind of a light area. Well, what has happened is there's been a corrosion pit in there, and then this area down here, it's developed what's called a stress riser. And a typical way of identifying this type of failure is to see this area where it looks like an oyster shell. Well, what'll happen is this cross section of rod or bolt or whatever it is, but the cross section has been, or that part has been designed to a specific alloy that has specific ultimate strengths, tensile strengths, and yield strengths, and all of that kind of stuff, even if they include a service factor. In other words, make it bigger or stronger than it need to be. When you have this oyster shell type, it'll go clear across the entire section over a period of time, and then this area in here is a yield break. In other words, you have lost so much metal that it'll no longer carry the stresses or compression cycles that's required, and it'll break. So you had go slow, it goes slow, it goes slow, and then all of a sudden you have a pretty dramatic failure. This is a really common type of corrosion. This is a good one. This is on a fastener, and if you look, you can see what's happened. There's a torsion, actually a torsional moment, but this has been on an area where it's probably got a crack or a chip or a corrosion pit in it, and the strength of the fastener has been diminished by the reduction of cross section, and then this bolt is in, like I said, it's probably on something that rotates, and when it failed, just twisted apart kind of like a stalk of celery. But again, the original culprit of this is a corrosion pit that could have been solved by a corrosion preventative compound or even just a lubricant. There's a lot of metals out there. You know, I work mainly with ferrous metals, iron and steel. I work a fair amount for the military on aluminum alloys. So one of the things that you can do, and I think we're going to talk about this later, you need to identify the type of corrosion, and if you look closely, you can tell what kind of metal it is based on the color of the corrosion. Everybody knows that iron and steel rust is reddish orange, kind of like this one. If aluminum corrodes, you get aluminum. Aluminum is another whole story in itself. Aluminum corrodes immediately and forms a passive barrier to shield it from oxygen, and that barrier is called aluminum oxide. Aluminum oxide has a very close tolerance, a very narrow pH range, and if you get too acidic or too alkaline, the aluminum oxide starts to slough off into, as it shows here, a white powder. So iron and steel is orange, aluminum is white, lead, by the way, is white. Copper, let me try something here. Yeah, these slides are backwards. Copper has a number of oxides. It can be, like cuprous oxide is red or yellow. If it's a sulfate, green or another white powder, and copper acetate is blue. This particular messy looking thing here is the sump of a gas station convenience store that uses ethanol, and ethanol gives off acetic acid, and the acid reacts with copper and creates this oxide. First time I looked in a sump, I asked the guy, the sump, by the way, if you think of a submarine, the hull of a submarine is where the fuel is, and the conning tower is the sump. First time I looked in there, I said, "What's that big blue wire?" And he said, "Have another look." And when I looked, that big blue wire was a piece of copper tubing. The picture to the right, this kind of bluish thing has been brass, and the oxides of yellow metals are very, very similar. To give you an idea, I did a project pretty recently regarding this piece of copper tubing. This oxide will create corrosion pits, and I calculated if the corrosion pit is 5/1000ths of an inch deep. Now, hair runs up to about, depending, like black hair and that, runs up about 4/1000ths. So a 5/1000ths inch deep hole, which is a little bigger than a hair, will reduce the ultimate strength of that piece of copper tubing by 15%. And if that particular copper tubing happens to break, it pumps raw gasoline into the sump in a convenience store. And my only comment is hopefully that nobody smokes. But that's how you can identify both the metal and the oxide. We saw that. As I said, in order to have corrosion, you have to have both moisture and water. There are a number of products that keep moisture away or try to keep moisture away, and there's some that try to keep, well, moisture is water, but keep oxygen away is what I was getting at. One of the approaches that we have taken is the oxygen molecule is really pretty fat, and it has the two hydrogen molecules on each side. A lot of our, but not all, a lot of our products are solvent based, and the solvent is of a small molecular size, number one. The weight of water itself, the specific gravity, is 1.0, and it's 8.34 pounds a gallon. If you put, and you can tell me this, if you put water on gasoline, what happens, or gasoline on water, eventually, even if you shake it up, the gasoline will float on the top because it has a specific gravity that is less than water. So the reason for, number one, our solvents are very small molecules, so they'll fit underneath here, and they're heavier. There may be somewhere, depending on the solvent, from 25% to 33% heavier than water. And they're called hydrophobic. So in an area where you have moisture, you put a product that we make on that has a solvent, and it gets underneath the water, and the solvents have what's called low vapor pressure, and they evaporate. But when they evaporate and leave, they actually lift up the water molecule and take it with it. And that term is called hydrophobic. And we're actually getting to products now that are called super hydrophobic. We said earlier, pHs make a difference. If you live near something where there's sulfur, coal-fired generator plants, paper mills, even, believe it or not, sewage treatment plants, you're down on the acid side. If you live near the water where there's a lot of chlorides, then you're up on the alkaline side. The biggest thing that you could do to solve your corrosion problems is to notice what's causing them. We have in our plant a number of drums of different products. So if we give you a checklist, and we're going to ask you a number of things, but basically we're going to ask you what the metal is and what's the environment. And if you say the environment, you live by an electric plant, then the products will need to have a lot of the ingredients that protect against acid. And if you live on the beach and you have a lot of salt spray, then you need to get a product that is on the basic side. So very important to know your environment. Here's one here. This is in a storage area for fertilizer. The title says salts and chlorides. The salts can be a lot. This one is table salt, which is on the alkaline side. This is a fertilizer, and they use sulfuric acid to make the fertilizer, and there's a residual in the fertilizer itself, and over a short period of time it off gases and floats and just, if you would, eats everything. There's a lot of different metals on heavy equipment, iron, steel, and probably copper. I doubt if there's aluminum, but there could be aluminum panels or something. One of the things I like about this slide of a boom is, number one, it's corroded, which, and see, it's been painted, and you never want to paint over corrosion. And I'm not sure if there's another slide, so I'll tell you now. We are working with a large equipment manufacturer that does the beach restoration. And they were actually sandblasting their equipment, priming it and painting it, and the rust showed up again. Even I didn't know, and I hate to admit this, I didn't know that a product that is sandblasted still has iron oxides on. So until you get rid of those or neutralize the iron oxides, you can do whatever you want to it, and the rust is going to come from the inside out. The other thing, and you noticed it's orange, so it's iron or steel. The other thing that is important on this, and I may have already said it, but when a boom like this, lattice boom, I think, is under load, you have compression on one side and tension on the other. And the tension stresses, as I've shown you on earlier slide, particularly with corrosion pits or environmental cracking, you can get a failure. The load reading on a crane could be something, but if you have corrosion pits in the boom itself, it's going to fail way under the working load strength. Another problem, and it sounds like all we're talking about, but things that's under consideration is, if you would, nothing is free. And what that means is you get, and I used to have this when I designed conveyors, you want the product to last a long time, and you want it to resist abrasion, like if you're dragging it, or in my case, we had conveyors, and it was conveying abrasive materials. So in order to make the piece of equipment last longer, people hardened the steel, or they used steel alloys. And what happens is, when you harden the steel, and we'll get lines 2 and 3, it talks about medium carbon steel quenched and tempered, and medium carbon alloy steel quenched and tempered. As you harden the steel to make it more resistant to abrasion, and you can case harden them, you can actually freeze them until you get a hard coat on. Every time you do that, it does make it more resistant to abrasion, but it makes it less ductile and more susceptible to shock loads. For example, in my conveyor experience, if you were dragging something, you had a drag conveyor and you made something very hard, a hard case on it so that it resisted abrasion. If there was a dam and the torque went up real high, a lot of times the round parts would fail because they're not ductile anymore. Quenching, carbon steel, this is probably 1018, 1020. They have different yield strength, different average ultimate strengths. Quenching, there's several crystal structures of steel, like body center cubic, face center cubic, and it has to do with the temperature. In other words, steel is has one crystal structure, and when you raise it above 1300 and some degrees, it changes the crystal structure, and when you raise it up to, I think, pushing 2000 or 3000, it changes the crystal structure again. So remember, if we want some hard case steel, we can, in a heating oven, bring temperature up to, say, 1800 degrees and then quench it. And what that means is you would dump it in oil or water, or dump oil or water. Most of the time people use oil because the water vaporizes and doesn't do well. So you can have oil and you can quench the steel, and what happens, instead of going back down through the normal crystal structures, kind of freezes it in the crystal structure you want. Tempered steel is steel that you have heated and then put in a tempering oven, and you have allowed it to come back down to room temperature at a much slower rate. So it's not frozen in time, if you would. Alloy steel, usually they add nickel. You can pick up a lot of ultimate strengths out of using nickel. Same thing, they can quench it, they can temper it. But as you have to know really what you want. If you want something that'll stand with shock loads, it'll help withstand the corrosion pits and stress cracking. If you get a hard coat on it, it's just absolutely, it's going to rupture. Stainless steel is just that. It is steel that stains less. There's a lot of varieties. Some of them have carbon in, those stain. 300 series, there's 400 series stainless, and then there's some different stainlesses. Disadvantage on the ones that, like 300 series, is more resistant to staining or rusting, but it's not very strong. And as you add carbon, it's stronger, but it rusts quicker. The big deal to me, and I've been doing this, I hate to admit, since 1979, you have to know the environment. Look around. See what is, we actually have a checklist that you're more than welcome to get, but look at what is causing your problem. And that's all I mean, I could talk forever on that, but you've got to look around and see what your environment is.
Okay, so hey, right, we're going to take any questions. If anybody has any questions, just type them in the box here, and we're going to keep going. And I'll have Ron pop in and answer these questions as we go. Again, this is audience participation, so please ask a question or two. Okay, so now we know what corrosion is. We're going to talk about preventative maintenance. And you know, again, small problems turn into big problems, and I'm a believer in preventative maintenance, and I know a lot of the big companies out there, they got big because they did practice preventative maintenance. So when you start choosing a preventative maintenance program, you gotta figure out what some of your factors are. So again, do you need to displace water? Are you in an area that has lots of rain, lots of water, lots of salt spray? So if you do, snow. Also, you got to pay attention. Do you want to push that water out? So what kind of specific gravity are we working with? You know, there's a lot of cheap products. There's a lot of cheap products out there that are made from cheap grease and cheap mineral spirits and thrown in a can. If you look at their specific gravity, it's like a 0.8, and it basically floats. Hang on. So also, you want to know how long do you want your problem to last, or how long do you want your equipment to last? Again, these beach restoration equipment, they cost $1 million. Okay, how long do you want it to last? What type of lubrication do you want? So there's some other factors for you. Hang on one second. I'm going to get Ron. So one of the things we talked about in this webinar is nanotechnology. This is new technology, and I would like you to think about nanotechnology. I'd like Ron to explain it just for a second.
This is kind of a neat, fairly new, not real new, but a really kind of a neat subject. The simplest way, if you're not familiar, in this case, we make products and we send them to a company that encapsulates a specific product in a nanotube. And I like to talk about it because I like to eat. It looks kind of like a very small piece of macaroni. And you can buy, or I can buy, now remember, I'm supplying the corrosion preventative compounds, and I can buy nanotubes with different wall thicknesses. The reason that's important is just for, let's just say that we put a corrosion preventative compound on the outside of something to protect it. And included in the regular corrosion preventative compound, we have nanotubes with even more of the corrosion preventative compound. One of the projects I worked on is at a dock or port, and you know the bumpers where the boats hit, or not supposed to hit, the boats lean up against or whatever. We actually treated that with corrosion preventative compound, and then we bought nanotubes that the wall thicknesses were pretty thick, so it took a lot of pressure to break. If you did this on an automobile or on a piece of equipment, the idea being these nanotubes or these capsules will rupture. So if you scratch it, bump it, a ship runs into it, then it will rupture these nanotubes, and the nanotubes will release more corrosion preventative compound and seal the area that's scratched. So it's just new, but I think it's something you ought to pay attention to.
Okie dokie. So let's move it on. Okay, so as you know, we make corrosion preventive compounds. It's a liquid. A lot of people apply them in a coffee can and a magnet. You know, a lot of people put them in by a salad strainer or a pasta strainer. But here's two different ways to do it. One is a dip process, kind of a plunging process. Very, very easy to use. And here's another one, a dip. You just dip it in, pull it out, let it drain. And so if you're going to do a batch of screws, just do it. It's easy, simple, and just pour it back in the bottle. This also lid stays on pretty tight, and our stuff doesn't evaporate. So those are two options for you guys if you have corrosion there. A lot of people brush on. I'm talking to a guy right now who's got all his safety metal decals on his crane. They're all rusting. If you can't take them off, you can just brush it on, get yourself a pair of gloves, and brush them on. Next. We also make it in aerosol, and a lot of people use this product over here. Get to know this product. It's called a Sure Shot. You fill up a quart or a half a pint or a pint, get a bicycle pump, and next thing you know, you got an airless sprayer. Awesome piece of equipment. As you know, I was in the crane business, so one of my goals is to help people when a crane comes back from rent or amusement ride, goes through its monthly check, put your inspector there with a Sure Shot. Or write it down. These places need to be shot with corrosion prevention compound. So any questions? Come on, guys. We have a few minutes. So just fill in the, put it here on the side. No questions? Okay, come on. Okay, the last phase of this program is to be about exterior corrosion. Again, we go to these crane auctions. We go to the big auctions, heavy equipment, and the saying is the piece of equipment has to look good from 150 feet away. That's a good example of what you're seeing is uniform corrosion. And what we find is people pay down and dirty, get it sandblasted, prep it, prime it, and paint it, and the rust is still there. And that includes critical components. So what we're going to talk about is what to do after you blast. And be careful how much metal are you taking off your piece of equipment. So here's some good pictures of stuff that is rusted. As you can see on this one, this is an aerial lift down in Miami. They painted it. The rust came right back through. Okay? As you know, chains rust a lot. And the key is these free iron oxides. We have to destroy them. It's a living, breathing thing. And our product stops free iron oxides from living. Okay, so before you paint or after you sandblast, try and kill the free iron oxides. It's simple, it's safe, it's easy to do. And I really, really recommend it for the crane guys and the amusement rides when you see a chip of paint. Okay, again, here's some rust underneath the paint. This is my good friend Howard Kaplan saying this, rust underneath the paint. It's a big problem. Small problems turn into big problems. Again, no use of a way to convert free iron oxides. Okay, I want to talk to you a little bit about corrosion conversion. As you can see right here, I don't have one on a crane, so I'm using one from a gas station, but nasty corrosion, ½ inch thick. Instead of sandblasting it, we simply scraped it, got all the rust off, got down to the base metal, and applied our corrosion preventive compound on there. That's how you do it. We simply convert the rust so there's no free iron oxides. Simple, safe, non-flammable, and it's water-based, and it's a process. So again, when you go out and look at equipment, you inspectors out there, and you see rust, treat it. There is a simple process to treating it. So how do we get rid of the rust? 3 ways. Basically, start scraping, which is an easy way. Wire brush, or some guys sandblast. Be careful how deep you sandblast, though. But if we're on top of it, we're doing preventive maintenance. All your guys need to do is a scraper and a brush. Simple, easy to use. A little bottle of water, and you're ready to go. Okay, here's our steel curtain. Here's a good example. This is a sheet panel from a crane. It started off with a lot of rust. We basically scraped it, put our corrosion preventative conversion product on there, and within about 2 hours, It turned completely black. Let it dry another hour and you're ready to paint. How hard is that? And you know you've killed it when it's black. If it doesn't turn black, you haven't killed it. Simple, safe. You can do it with a paintbrush or you can do it with a Sure Shot. Okay, so in conclusion, old school, prep, paint, and paint over rust, this is the results you're going to get. Or new school, corrosion conversion, paint over no rust. So we like to say that around here. So when you're going to choose, sorry about this, but the computer's messed up a little bit. But so when you're going to choose a corrosion converter, here's some things you need to consider. Worker safety. As you know, there's a product out there on the market. It's green. It's been around a long time. I encourage you to check the MSDS sheet, and I don't encourage you to put your hand in it. It's nasty. It'll burn. And we just had a guy the other day. He was using it. He dripped it on his foot, on his shoe, and it ate through his shoe and ate his skin up. How much time do you have? How much labor? What's the dry time? Again, ours dries and cures in 3 hours, and you're ready to put paint on it. Very simple, very easy to use. A lot of these guys, these corrosion conversion products out there, you have to wait 24 hours or 48 hours for it to cure. And as we know, a lot of things could happen in 48 hours. Any questions? Come on, we need a few questions. I got still people on here. Okay, we'll go to the next spot. So in conclusion, this is going to conclude this webinar. I'll just say this. Small problems turn into big problems. Cranes and amusement rides are expensive. And protect your people, protect your assets. And I think this says it all. Benjamin Franklin, he got it right. So if there's no other questions, you can always email me at djenkins@grapplehook.com, 813-877-4665, but that's it. So I appreciate it. Oh, we got a question here. We got a question for Ron. Okay, fire away on those questions. It says, you mentioned lubricating fasteners to prevent corrosion on fasteners. Can you elaborate?
Yes, what we make are one of a series of products that we manufacture is classified as a lubricant that contains corrosion preventative compounds. But basically, anything that you put on there, I won't say anything is better than nothing, but putting a lubricant on the fasteners does put a film, if you would, that helps shield the area from moisture. A lubricant on a fastener makes it easier to mate and unmate. You won't, and if you can prevent the fretting corrosion, you've prevented the galling, and it'll be easier to take it apart. So there's several products in the market, but again, the products that we make, the lubricants have corrosion preventative compounds. There's another question. Is it food grade safe in water? First of all, I'm not sure which one of the products that you're talking about. The products that we make, we have never had them in contact with food, so I'm going to say no. We make solvent-based products, we make water-based products. Product that I made today for the military is a water-based product, and it's going on aluminum. So as I said earlier, nothing is free. The advantage of solvents is the solvents that we use and other people use are solvent cleaners, so you don't have to work quite so hard at getting the oil and soils off, and solvents tend to dry very quickly. Our solvents actually dry in a matter of seconds, and I'm talking 2 or 3 seconds. Water is less expensive. You have less environmental problems with it. Water will take longer to dry, and it has a tendency to what they call slump. In other words, if we put a solvent product on a vertical surface, it'll dry and stay where you put it. If you put water on that vertical surface, it has a tendency to pool, and it'll go down to the bottom. So again, nothing is free. How difficult is it for standing amusement parts to Actually, as far as putting it on, the product that I'm making now is going on airplanes, and I told the people to use a garden sprayer. A lot of water-based products. You could put in a Home Depot type water sprayer, or what do you call it? Bug sprayer, and you pump it up and spray it on. Very easy to apply, and particularly the water-based. Amusement park rides that are putting up and taken down a lot. Actually, it would be very, very beneficial for that, because the fasteners would mate and unmate very, very easily. You can't, you have to use a wrench or something, but your rides are going to vibrate, and I would think that as they vibrate, there would be a tendency for fretting corrosion. So as far as putting it on, the solvent-based, the best way, and it's less expensive than aerosol cans, are these things like the Sure Shot. We use one that's a liter, and you can bump it up with a bicycle pump if you want to. So I would certainly use them on amusement park rides. Fish industry, you're talking chlorides, and then chlorides. We make a product, there was a picture called Corrosion Zero that's very effective against chlorides. We're at Port Manatee, and there is actually it's Morton Rock Salt, has a rock salt bagging piece of equipment. And it's a nice place. I'm being sarcastic. On a summer day, the ambient temperature will go 120 or 130 degrees, 100% humidity, and we have a sample rack above the spout that where they fill the, I think, 40-pound bags. With no protection, 1010 still corrodes in a day. We treat a piece with several, that's where we test our products. And the ones that we do with Corrosion Zero, we left up, I don't know, 2 or 3 months. And when we brought them back to take pictures of, I actually put them in the sink, had to wash the salt crystals off of them. So salt was growing on the piece of metal without corroding it. How long does a product last? It's a good question. In addition to corrosion, you have erosion. For example, if it's on the outside of a boat or something that's moving through a fluid, and that fluid can be water, on airplanes actually it can be the air molecules, you have a certain amount of erosion. In a boat, for example, we make a product, Supercore A, and we make another product, Corrosion Zero. On the electrical connectors and the, where all the wires come together, fuse block, I think, we suggest reapplying it once a year. And the reason we come up with once a year is we didn't know how long to tell somebody, and it doesn't rust in a year, so that's the answer that we give them. Another gentleman asked, are the products registered by the EPA? They're not registered, but we're doing an awful lot of work in the fuel sumps, and they are approved. So I'm not sure if, I can't read either. Regulated, that's close, registered, regulated. All of our products come with material safety data sheets, and we use no hazardous products. So the products that we use have been reviewed and looked at. When I say products, let me try that again. The ingredients that we use have all been looked at by the EPA. And the gas station stuff or convenience store stuff is actually very, very shortly going to be required by the EPA to keep the gas sumps from corroding. And they can't specify our product, but they can say such and such a product or equal. And right now we're the only one that happens to be making. There's another question on the zinc-based paint primers. They've been around forever, really well. We didn't talk a lot about it, actually none at all, galvanic corrosion. That is another entire type of corrosion. And what happens if any of you out there have boats, for example, that's in salt water, or equipment that's exposed to salt water on a regular basis? Has anybody ever heard of a sacrificial metal? And what that means is that you put on, in the case of a boat on a transit, a piece of zinc or two, and they have their electric potential is very low. So instead of the corrosion eating your outdrive, it'll eat that piece of zinc. So the zinc primers work, they're very, very effective in galvanic type of corrosion. Our products are more for, they wouldn't work as well in galvanic corrosion as some of zinc. Can the same corrosion products be applied to the metal and electrical components? Yes. For example, on the airplanes, they're used on the avionics, electronics, as well as on the landing gear, the flaps, the tracks, and all of that stuff. In the gasoline sumps, after it's cleaned and the rust converter is applied, then we spray absolutely everything. We try to use a lubricant that has pretty small molecule so that it fits in tighter tolerance places. We actually did a project for a company, and just by changing the molecule size, which allowed the electrical connectors to be lubricated, we reduced their warranty problems by 52%. So yes, you can use them both on the metal and on electrical components. However, as I think of it, I probably wouldn't be spraying water-based product on an energized electrical component, which brings up another point. None of our products are flammable. So I have actually taken our product, Supercore A, and personally sprayed it on electrical connector, electrical set of contacts, 460 volt, 3-phase, and I did that without turning the electric off. So, so I'll say solvent-based products could be applied to the metal and the electrical components. Water-based products, I wouldn't want to do that. Tabasco, how do you feel your product would work in an area handling Tabasco? That's instead of using Rolaids, I guess. Tabasco is terribly acidic. And if you saw our, and I may have said this, if you saw our blending area, we have drums, and this drum is for acid, this drum is for something else, this drum is for something else. So, for example, the Corrosion Zero, and keeping in mind where we live, is very, very effective on chlorides. It would be very easy to increase the amount of product that makes it resistant to acid. So again, if you know the environment, you tell us the metal. We even make a corrosion preventative compound for shipping people, like on top of ships, and we can, by adjusting the ingredients. Remember the old creosote that is really hard to put on and worse to get it off? We make a product that by jiggling the formula, we can make it last anywhere from 3 weeks to 3 months. And then you don't even have to take it off. It just kind of goes away. How does your product affect the coefficient of friction on two surfaces? Obviously, if we're using, that's a good question actually. If we're using the lubricant, it would reduce the coefficient of friction. We also make a number of products that have PTFE in it. We just come out with a new product for the military. It is corrosion preventative compound and dry lubricant. And the lubricant in that case, and it's approved on the, let me think, C130, B52, and C5A. That product is corrosion preventative compounds with PTFE in it. So if you tell us what you want, then we can blend a product to fit your own application. So yes, we can dramatically decrease the coefficient of friction. There's also, I happen to like molybdenum, which is a very good extreme pressure ingredient. The harder you squeeze it, the slipperier it gets, so it would be very easy to work that into one of our products. Hopefully that helped a little bit, but if I can say just one thing, pay attention to what is going on where your corrosion shows up, and just tell us, or anybody, but hopefully you'll tell us too, where you're at, where you want to go, and are you around the water or acid or whatever. So I do thank you guys and ladies for attending, and I'll turn this back over to Dan.
Okay, thanks everyone for your patience. We did a whole hour. If you have any questions, just email me, djenkins@graplock.com. Got information, a lot of videos at theironox.com. And I'm going to conclude this session. Once again, thank you. I'm going to close it, so really appreciate it. Thank you again. Bye.